Well, greetings, mathletes, and welcome back. So last time we entered factoring land by looking at the process of grouping. Okay, so grouping by itself is a pretty good process, but if we add a couple of things to it, we can factor almost anything. So what we're going to be adding to it is something called the master product. Okay, and so we're looking at the master product and grouping together. And what that will allow us to do is to factor trinomials with it. Now, after we look at those and we get an idea of the process, we're going to take that and then start using those things in unusual situations, in combination with other factoring things, and we're just going to keep going from there. Okay, so let's go ahead and get started here. Yeah, I think the best way to do this is with an example, as far as explaining the procedure. So we're going to be looking at the master product and grouping. And just so you know, most of the time when people say this, a grouping is its own process. But when they talk about this method, they usually say the master product and grouping, because the master product is really not used for anything else. So let me explain to you what the master product is, right? It's a tool we're going to use to scoot that up. It's a tool we're going to use to figure out how to split up this middle term so we can make it 4 terms again. Because if you remember the grouping process, it requires 4 terms because you factor the front 2 and you factor the back 2. So that makes 4. I only have 3 terms here. That's a problem. So here's how we end up going through this. So I like to organize it this way with an X. What's going to go on top is our master product, and then what's going to go on bottom is a sum. Okay. Now here's where the numbers come from. The master product is the product of the first coefficient times the last coefficient, right? So this is dependent on the fact that you've written your polynomial in the correct order. So the exponents descend, right? This one has a 2, this one has a 1, and technically there's a 0 here, even though we never write that. Oh, let's make it look like a 0, right? So as long as you have it in that order, you multiply the first coefficient times the last coefficient. 2 times 3 gives me 6. So I'm going to write 6 here. That's my master product. The sum is just the coefficient of the middle term. Okay, and this is how we use this tool. What we are looking for are 2 numbers whose product is 6 and whose sum is 5. So if we think about things that multiply to give me 6, right? I have 1 times 6 equals 6. But 1 plus 6 is not 5, right? So I can't use that. And then 2 times 3 is equal to 6. And 2 plus 3 is 5. So that's what we want here. We want to get the numbers that multiply to give us the top number and add to give us the bottom number. Okay? Now, once we find those things, we're not done. These 2 numbers actually turn out to be the magic numbers for tearing this number apart, your middle term, this guy, right? Because 2 plus 3 is 5, that means that I can rewrite 5x is equal to 2x plus 3x. So that means I can take that 2x plus 3x and replace the 5x with it. So let's rewrite this whole thing. And by the way, it doesn't matter which order you put these in. You can put the 2 first or the 3 first. You could write 3x plus 2x. That'll work just as well. But what we're going to do is split this guy. So this is now 2x plus 3x. And then we put everybody back, right? 2x squared plus 2x, and then 3x squared, we'll put a plus 3 here. And you notice we have 4 terms now. And so if we have 4 terms, that means I can use grouping. Or I can at least try. If I have the correct numbers here, right, this will work. If those numbers do not exist, right, if you've gone through every factor of 6 and none of them work, then that means that the polynomial is prime and it doesn't factor at all. So let's go ahead and factor this guy. We'll see if we were right. So we'll split front and back. Let's see, 2 is a common factor, and it also has an x in each term. Okay, and that's going to leave me, let's see, 2x times x gives me 2x squared, and then 2x times 1 gives me 2x. Okay, and now we have to do the same thing on the back end here. So if I look at this, 3 is the common factor between the back two terms, and this is a plus, so that means that this is going to be a plus 3. And that also leaves me with an x plus 1. Oh, I wanted to color code that. Let me... Right. Hey, now. There we go. I wanted to get that color coded. There we go. Now, looking at this, you notice x plus 1 is the common factor. So we'll pull that out. And that leaves me with a 2x. Why won't that change? Are you kidding me? There we go. Okay, try this one more time here. That leaves me with 2x plus 3. Right? And now I have the factorization. And if you want to make sure it's right, this is the answer, you multiply it out. Right? So let's see if we can FOIL this out. I'll write the answer over here and we'll see if it matches up. So x times 2x is 2x squared. X times 3 is 3x. 1 times 2x is 2x. And 1 times 3 is 3. And if I collect the like terms in the middle, I get 2x squared plus 5x plus 3, which matches. Right? It's the same thing we started with. Notice that when I factored it, these guys were in a different order. Or when I multiplied it, those guys were in a different order than over here. That's okay. Right? It's because you're collecting them anyways. Plus, it's addition, so you're allowed to switch the order. Right? So, that's the process. So we start by multiplying the first times the last term. Right? And that gives us our master product. The middle term is our sum. And then we find the numbers that multiply to give us our master product and add to give us our sum. And those numbers tell us how to break up the middle term so that we can use grouping. And then once we have the middle term broken up, we can just walk through the grouping process as normal. Right? No muss, no fuss. All right, so let's look at another example here and see how you do with it, because this one's going to be for you, because I'm a giver. Okay, so let's see what you can do with this one. Let's do 4x squared minus x minus 5. And you want to be careful with this one too, because it's a little tricky. You have to mind the signs on it, but I want you to take a stab at it and see what happens. Right? Keep in mind that if you have a negative product, that means one of your numbers that you're looking for is going to be positive and one will be negative. Otherwise, I can't multiply them to get a negative number. So go ahead and pause it here, and then we'll take a look. You paused it, right? Okay, so let's go ahead and take a look. See what we got here. So let's take a look at our master product first. So let's see, 4 times negative 5. You have to honor that. You have to honor this sign. So let's see here. So we'll get our x. 4 times negative 5 is negative 20. And then this is a negative 1. Okay, so what I'm going to need are two numbers that multiply to give me 20 and add together to get negative 1. So you do have to honor these signs. Now, here's some things we can deduce from these signs. You know, when you add, first of all, when you add two numbers, right, when you add two numbers together and they have different signs, the sign of the answer is always the bigger of, you know, and I'm putting bigger in air quotes because, you know, technically a positive number is bigger than a negative, but the number that's bigger is the one that carries the sign of the answer, right? So if it's negative 6 plus 12, Well, 12 is the bigger number and it's positive, so the answer is going to be positive. So that's the first thing to notice. And then the other thing to notice is that if I have a negative product, that means the only way I'm going to get a negative number when I multiply these is if one of them is positive and one of them is negative. That's the only way. And so I'm going to look at things that multiply. Now, keep in mind, you're going to be doing this in your head most likely, but you're going to go through the factors of negative 20 until you find a pair of factors that adds up to negative 1. And I like to do this systematically. Okay, so we have 1 times 20. Now, here's what you want to be thinking about too, right? This goes back to the signs. If I'm adding these two numbers and I get a negative number, that means the one that's negative is going to be the bigger number, right? And if the negative one's the bigger number, I can just start marking the bigger number as negative. So that gives me negative 20, but they only add up to negative 19. So we'll try 2 and negative 10. Let's see, that multiplies to give me negative 20, but only adds to give me negative 8. 3 doesn't go in. 4 goes in, so it would be 4 times negative 5. And 4 times negative 5 gives me negative 20, and 4 plus negative 5 gives me negative 1. So those are my numbers. I need a positive 4 and a negative 5. Right? That's what I'm looking for. And again, you can break up that middle term any way you want, but because negative x is equal to 4x minus 5x, right? That's a true statement. I'm going to take this 4x minus 5x and substitute it in for this negative x. So now what we're looking at is 4x squared plus 4x minus 5x minus 5, right? And that is totally set up for grouping now. So that's what we're going to do. Let's go ahead and group this guy. So we'll split front and back. Looks like 4x is my common factor in the front. And that'll leave me with an x plus 1. And then looking at the back, 5 is my common factor, but notice this is a negative, right? So this is the sign of whatever you pull out. So it's negative 5, and then we'll see what's left in the parentheses here. So negative 5 times x gives me negative 5x. Negative 5 times 1 gives me negative 5. And now I can see x plus 1 is a common factor. And 4x minus 5 is my other factor. Right? And for the sake of time, I'm not going to foil this out, but if you want to check it, you just foil it back out and see if you get the original polynomial back. And as long as you do, then it is a correct factorization. Now, there are some problems we run into because what we're really looking for is a complete factorization. So if something factors more, right, you won't be able to tell that by multiplying things out. That's one of those things you just have to be able to catch it. Okay, so let's look at the next example here. Oh, I hit a wrong button. Okay, let's try that again. There we go. Okay, so let's try a tougher one this time. I've actually made those numbers kind of nice. So I want you to try this one now. Let's make sure my pen's on. 10x squared minus 3x minus 4. Okay, so that's your polynomial. And go ahead and pause it here. See if you can walk through the whole process. You have all the tools you need right now. Okay, well, hopefully you were successful. Let's see if we can walk through this. Okay, so we need our little magic x here. Let's see, 10 times negative 4 is negative 40. That's my master product. Negative 3 is the middle term. That's my sum. Yeah, this is one of those things where, maybe we'll have to write some things down. Keep in mind that going through the factors is normally something you do in your head. It's just by knowing your multiplication tables. But once the number gets big enough, you're going to miss factors. You know, if that master product ends up being something like 260 or 360 or 1024 or something really big like that, you have to get creative and start writing things down. So, nonetheless, let's see what we can deduce first. So first of all, it's a negative master product, which means I have a negative and a positive factor. Okay. Second of all, the sum I get is negative, which means that the bigger factor is going to be negative. Right? Those are the things that I've just deduced. So the bigger factor is going to be the negative one because that's negative. Okay, now, so let's go ahead and take a look at factors of negative 40. Now, you might spot it right away, but I'm still going to go through this systematically. So I know the bigger one's negative, so it'd be 1 and negative 40. Well, that's not going to add up to negative 3. 2, negative 20, nope. 3 doesn't go in. 4 goes in, but that only adds up to negative 6. We're not there yet. 5 goes in. Let's see, that's negative 8 times. 5 plus negative 8 is negative 3, so those are my numbers. So it's negative 8 and positive 5. So that negative 3x is now going to get rewritten as negative 8x plus 5x. So now we have 10x squared minus 8x plus 5x minus 4. And we just need to go through the grouping process now. Right? My common factor back here happens to be 2x. And if I pull 2x out, let's see, 2x times 5x gives me 10x squared. 2x times minus 4 will give me negative 8x. Okay, so that's good. We got that part. I'll make a little room here. And then the back half, let's see here, 5x, 5 and 4, 5. No, there's no common factor other than 1, but this is one of those places it's a really good idea to write the 1 because otherwise you end up forgetting it. Right? So it's just 5x minus 4. Okay, so now I can see 5x minus 4 is my common factor. And I can see the other factor is 2x plus 1. Right? And so I have a complete factorization now. So that was fun, right? Go home, tell your friends about it. Well, you're probably home already. Just show your friends. Make them watch the video, right? Even if they're not taking the class. A little math never hurt anybody. I like to work on stuff in the evening just for fun, so why not? And speaking of fun, I got another problem here we can work on. So here's your next task, and I think we'll have looked at all the little different ways this can be approached once we finish this one. So let's look at 6x squared minus 17x plus 5. Right? That should be a pretty good challenge for you. It's a little bit different reasoning on the master product, but let's see if you can work it out. So go ahead and pause it here and see what you can come up with, and then we'll work it out. I'll go ahead and work it out, and we'll look at it together. I'm just making sure you're working. Okay, so let's go ahead and take a look here. So again, with our master product, 6 times 5 is 30. Okay, so that's pretty good. And then our master product is negative 17. Now, there's some different things about the master product now. Okay, so our master product is positive. Okay, so you think about it. What are the ways you get a positive number when you multiply two numbers? You get a positive number if you multiply two positive numbers, and you get a positive number if you multiply two negative numbers. So what a positive master product is telling you is that these numbers that I'm going to find are both going to be the same sign. Right? Okay, now if these two numbers are going to add up to a negative number, that means they both have to be negative. So I'm just going to put that in first so I don't forget. Now I can go through and start looking at factors of 30. So let's see. -1, -30, that definitely doesn't add up to 17. -2, -15. Hey, that adds up to -17. We got the winners here. So it's -2, -15. So that means we're going to rewrite our middle term as -2x minus 15x. So we get 6x squared minus 2x minus 15x plus 5. And incidentally, I mentioned this earlier, but if you wanted to, you could totally swap the order of those two things. If you put the minus 15x first, you'll still get the right answer. What'll happen is you just get the factors in the reverse order, which is still correct. So in any case, now that we're here, we can do the grouping process again. So looking here at the front end, 2x is my common factor. And let's see what that leaves us. So if I pull a 2x out, that leaves me 3x minus 1. And then the back end, let's see, 5 is the common factor, but this is negative, so I pull out a -5. And if I pull out -5, that leaves me with 3x, and -5 times -1 gives me +5 back again. So I can see 3x minus 1 is now my common factor. And that leaves me with 2x minus 5 as the other factor. And so we win, right? But you notice how much the signs of the master product and the signs of the sum you're looking at help determine the signs of the two numbers that you're trying to find, right? So those are important clues. You need to be able to reason through those things. Okay, so at this point, I think we have pretty well covered all the little cases of the master product. However, the master product doesn't always work, and it often gets used with other things. So we need to take a look at those now. So let's go ahead and take a look at what happens when you start mixing the master product up with a few different unusual situations. Okay, so let's take a look at this. So 8x to the 4th plus 20x cubed plus 12x squared. And this is one of those dark alley situations. You're walking down the dark alley, someone jumps out from behind a dumpster and wants you to factor this at gunpoint. These things happen. This could save your life if you know what to do. So looking at this, there's a few differences right off the bat that you probably notice. Usually the biggest one people notice is that this is to the 4th power, right? This goes 4th, 3rd, 2nd power. Normally we go 2nd power, 1st power, 0th power. So what do we do about that? Well, oftentimes, in fact, you always should do this. I skipped over it a little bit because we were focusing on a new method, but you always want to start every single factoring problem, with the same idea. You start by looking for a common factor. If it turns out the common factor is 1, then you just move to the next step and see if you can use another method. So looking at this, well, actually, let's get this arrow off because that's not important anymore. Between 8, 20, and 12, 4 goes into all of those. So I can pull a 4 out of there. And then between x to the 4th, x to the 3rd, and x squared, there's an x squared common. So I can pull that out. So that's actually my first factor, is a monomial. So this has a monomial factor. Now we have to see what we're left with. So 4x squared times 2x squared will give me 8x to the 4th. And then let's see here, 4x squared, let's see, it'll be times 5 to get 20, and then times another x to get x cubed. And then lastly, 4 times 3 gives me the 12, and then x squared is already there, so I don't need to put another one. Okay, so you notice what just happened. This is now something we know what to do with, right? That is a trinomial that we know how to factor. We've brought it down to being squared again. And this is something we can use the master product to factor. Now, what I like to do when there's multi-stage factoring, like you have to pull out a common factor, then you have to use this method, and then you have to use this method. Some of these end up having 4, 5, 6 different factors by the time you're done. So what I like to do is just pull out the thing that I'm working on at the time. It's kind of like, if you're going to rebuild a carburetor, it's a lot easier to do if you pull it out of the car and then put it back when you're done. Rebuilding it on the car is a little harder. So same kind of deal. So again, we have a master product. 2 times 3 is 6. And then we have 5. And I'm not going to color code this one. I'm just going to walk straight through it because we need to get used to seeing it just the way we write it too. Looks like 2 and 3 will work. And actually, if you notice, this is the first example I did. So we need to break up the middle terms. This time I'm going to put the 3 first just to show you that it'll still work. 3x plus 2x plus 3. Right? So you notice I didn't write them in the same order I got them here. And we'll go ahead and factor this. Let's see, front end, it looks like x is a common factor. And that will leave me with... Oh, I wrote an x cubed there. I just noticed that. Let me change that. What's wrong with me? There we go. So if I pull an x out, that leaves 2x plus 3. I just work here, guys. Okay, and then the back end, they don't have any common factors other than 1. So we'll write the 1 in. I can't emphasize that 1 enough. Make sure you get that 1 in there. That is really one of the more common mistakes, is to miss writing that term down. Right, so we have that, and I think we can see now. Oh, I said I wasn't going to color code it, but we can see it. Right, 2x plus 3 times x plus 1. Now, here's where you run into problems, is you start thinking, oh yeah, that's my answer. Well, that's part of your answer. What this is the factorization of this. So we need to split this guy up into 2x plus 3 and x plus 1. And then this guy comes down too. So the whole thing here is the answer. You have 3 different factors this time. Right, so you got to remember to pull that common factor out if there is one. Otherwise, basically what happens is your answer is not completely factored. Now, the other thing I want you to see, how can I do this nice? Oh, we'll use this one. Is that, what do you call it? What we really just did is like a prime factorization. So, like if I'm going to do the prime factorization of 30, oh, actually I won't write it there. Let's put it over here. Right, prime factorization of 30. I'm just picking that number out of nowhere, by the way. Well, let's see. That's 5 times 6. 5 is prime, so we'll keep that one. And then 6 needs to break up as 2 times 3. Right, that's what we would do to find the factorization of 30. What we just did is we took 8x to the 4th plus 20x cubed plus 12x squared, right, as a single thing like 30, and we said, okay, let's break this up into 2 factors. This is 4x squared times 2x squared plus 5x plus 3. Okay, 4x squared is prime because it's a monomial. Monomials are always prime. Over here, though, this thing continues to break up into 2 pieces. It breaks up into 2x plus 3 and x plus 1, right? And so these end up being all of our factors, the same way that we broke this up. And so what we're doing with these polynomials is finding their prime factorizations, the exact same way that we're doing, we do it with numbers, right? It's the same idea. What's harder is that we have to factor out. It takes a lot more work to figure out what multiplied together to give you a polynomial, right? That's the big difference. But this is exactly what we're doing here, right? This piece is illustrating the prime factorization of a polynomial. Okay, so that's that. You just have to make sure you look at every example for a common factor. All right, next, well, let's take a look at this one. Let's see what we can get out of this. Let's switch colors. Let's do 4x squared minus x minus 30. Okay, and I'll just tell you straight out, there's no common factor or anything here. See what you can find. So go ahead and pause the video here and see if you can factor this out. This one's a little tougher. All right, so let's take a look here. So I'm assuming you've worked everything out. Let's just go ahead and check through this here. So let's see. We have our, oh, get a little carried away with that x there. Okay, so our master product, 4 times negative 30 is negative 120, and we need the factors to add up to negative 1. Now, that's definitely possible because if I have one positive and one negative factor, which I need to because 120 is negative, then I know for a fact that these two have to be opposite signs. Now, one of the things I can keep in mind here is because this is negative down here, I know that the bigger of the two factors is going to be the negative factor. So let's see what things multiply to give me negative 120, because I'm not really seeing it right now. So let's see here. We have 1 and negative 120. Okay, no. 2 and negative 60. Nope, that doesn't add up to negative 1. 3 and negative 40. Nope, that's negative 37 when I add them. 4 and negative 30. Oh, negative 26. I feel like we're getting closer here. Let's see here. Does 5 go in? And 5 goes in. Well, I think, I strongly suggest that you guys double check things with a calculator if you're running out. 5 goes in negative 24 times. 6 will go in negative 20 times. 7, if you're not sure if 7 goes in or not, just try it. 120 divided by 7, and it doesn't go in evenly, so 7's out. What about 8? All right, so we got 8 and negative 15. Okay. What about 9? Does 9 go in? No, 9 doesn't go in. 10 goes in. 10, negative 12. Well, that adds up to negative 2, but that's not negative 1. Well, let's see here. 11 doesn't go in. 12 goes in, but we already know the bigger of the two factors has to be negative. So here's how you know when you're done searching. If you have checked every single number all the way down this list and none of them work, and you get to the bottom, and forgetting the sign for a moment, if it is a number that is on the other side of your list already, you are done. We have tried everything, and not a single thing worked. There is no common factor here other than 1, and there's no solution to our little master product problem, which means that this is prime. I want to point out to you that it is quite common that verifying that something is prime takes more work than factoring something, right? So if it doesn't factor, there's always the question of, what if I'm just not clever enough to find the correct factorization, right? So you have to go through and make sure you have checked everything to show that something is prime. And like I said, that often ends up taking more work. That often ends up being more work than factoring something is. Like just going through all of these guys was kind of a pain, right? It took up a bunch of room. In fact, more room than factoring would have taken up, and probably more time too. Okay, so you do have to watch out for prime polynomials. They sneak their little selves in there all the time. Okay. So again, There's one more situation, and this is one of those things. Later on, actually, probably in the next lecture, we're going to find a shortcut to do these so that we won't have to do it this way. However, I think it's important to know how to do it this way too, in case you forget what the shortcut is. You'll still know how to do these things. So if you happen to already remember the shortcut, that's fine. I still want you to see how to do it this way. So let's see here. Let's say we have 4x squared minus 9. You see the problem already. There's only 2 terms, right? We know what to do with 3 terms. We know what to do with 4 terms. We have no clue what to do with 2 terms. So, well, you can start just by looking for a common factor here. And it looks like there isn't a common factor, right? What does that do? Huh. Oh well. Anyways, let's try this again. Thought my ink might be drying up. So here is the shoehorn to be able to get this in. You can actually still do this by master product and grouping. What you have to do is put in the third term you're missing, right? It's there. It's just no one ever writes it. This is the same thing as 4x squared plus 0x minus 9, right? That 0x wouldn't be written in a final answer. You leave it out, right? Because there's no use for it. Any number that you plug in for x is just going to get annihilated by the 0. But for factoring purposes, it's useful. So if I look at this, what this does is it changes my master product problem to, let's see here, that's negative 36, and my sum is 0. And so that tells us some stuff. First of all, 36 is negative. So that means I have a plus and a minus in here, right? That is not a minus. I was writing the answer. I'm getting ahead of myself. Okay, and the 2 numbers have to add up to 0, which means it has to be the same number but opposite signs. Well, that's always going to be the square root of 36, right? That's 6, so it's positive and negative 6. That's the only way we're going to get 2 numbers that multiply to give me negative 36 and add to give me 0. It always ends up being 2 of the same number but opposite signs. And for this to work, your master product has to be a perfect square. Okay, now that we have 6 and negative 6, what that means is 0x can now be rewritten as plus 6x minus 6x minus 9. Suddenly we have 4 terms again. It's like magic. Actually, I'll be honest, a lot of mathematics seems like magic even to me. I've seen the explanations and it still feels like you're pulling things out of the air. Okay, so up in the front now that we're just back to the master product, or just back to grouping really, let's see, 2x looks like the common factor there, and that's going to leave me with 2x plus 3. And then over here, it looks like minus 3 is the common factor. And so that's going to leave me with a 2x plus 3. And lucky us, those match. So that means I have 2x plus 3 times 2x minus 3 as my final answer. Right? So that works out pretty good, actually. And it's kind of interesting. There are some patterns in here, and I encourage you to kind of notice patterns as you're going through and doing these. Look at the original problem, look at the answer each time you go through one of these, because you will see more of them in the homework. Yeah, see if you can figure out some patterns there, and then see if you can use the pattern to find the answer, and then work it out the other way and see if they match up. Right? We will see how to shortcut this entire process in the next lecture, but you might be able to figure it out sooner, and then the knowledge will be yours. It's not something that was given to you. It'll be something you built yourself. Okay, so let's look at the We'll go ahead and go through this next one. This will be our last example. This one, now that you've seen a problem like this, where you have two terms, let's see what we can do with this. Let's see if you can work it out. Okay, so see what you can do with this one. Go ahead and pause it here. Work on it yourself. See what you can get, and then we'll look at it together. Okay, so I'm assuming you've paused it at this point and worked. So let's see what we got here. Look, so we're missing a middle term, so we have to add that in there. So we get 25a squared plus 0a, and it actually doesn't even matter if you make it minus 0a because it's a 0. Everyone writes plus though. And then we have minus 4. Then over here, let's see here, my master product then would be negative 100, and that's good because that's a perfect square. And my sum will be 0. And let's see, that's negative, so I know I have a plus and a minus. They add up to 0, so they have to be the same number, and it ends up being the square root of 100, which is 10. So this and this end up being the way I'm breaking up that 0. So now we have 25a squared plus 10a minus 10a minus 4. So we'll go ahead and split that now that we have 4 terms. I mean, it's always remarkable to me when I look at this because you start with 2 terms, we turn it into 3 terms, and we take the 3 terms and turn it into 4 terms. Okay, so let's see. It looks like 5a, and that'll leave me with 5a plus 2. And then back here, it looks like minus 2, and that'll leave me with a 5a plus 2 as well. And that's my common factor. So we win. Winner, winner, chicken dinner. Don't expect a chicken dinner. And there we have it. And you notice it's very similar to the last one. The last one were the same terms, and one had a plus, one had a minus. And same thing here. I have the same terms. The only difference is that one's a plus, one's a minus. Right? So there's definitely patterns going on here. See if you can deduce them as you go through the homework. All right. So that's everything we wanted to hit today. We still have more stuff to do with factoring. We should be wrapping that up and all the special cases this week. And then the beginning of next week, we're actually going to find out why we're factoring in the first place, at least one of the reasons. So we will be using factoring to solve equations, actually. So in any case, until next time, keep your pencils and your wits sharp.